Today, we're setting up the PG Highfly stack. That's Postgres, Hikari connection pool, and Flyway database migrations. This is going to give you a solid foundation for your database projects in Java. Let's get right into it. We start with a mostly empty Maven project using Java 21. All we have is some logging and a little hello world. Okay, I've got two files. We're going to set up the application in here. And for running locally, we're going to use this entry point. The first step is getting a connection to a Postgres database. You do not need to install Postgres first. We're going to use a great library to help us with that. This is the Zonky.io embedded Postgres project. I love this thing, it's great. There's different embedded Postgres available out there. Others tend to need more configuration, more setup. This just works, it's really simple. If you go through the README, there is a bunch of documentation that's mostly aimed at using this in JUnit tests, which is great, but I prefer to code against the API directly. So let's ignore that now. First, we need a dependency, so let's add this Zonky.io dependency. It is called embedded Postgres io.zonky.test, and the latest version is 2.10. But obviously you would check that out yourself when you use this. Okay. And we're not going to deploy this as part of our artifact. We're just going to use it in the test scope. Our local run class lives in the test scope, so we can use it there without bulking up our artifact. Now let's tell IntelliJ that we've added something, and we can get using it right away. This is super easy. We just go embedded Postgres.start. Let's just throw exceptions. Yep. And let's log when it's completed. This actually starts a Postgres instance running locally, so we need to make sure we clean it up when we shut down. So let's add a shutdown hook. Right, so we just call pg.close. Now we need to surround that in a try catch. Okay, that'll do. So, let's finish that. So, let's just log when it's completed. Okay, great. And let's see if we can start this. Okay, we're going to see a bunch of logs here. So the first time, we have extracted a Postgres database, and it's unpacked it to a local directory. Let's have a look at that. Here it is. This is a Postgres installation. These are the Postgres binaries. There's a bunch of logging. You can see all the initialization. And, well, there's a whole load of things here. Okay, and it's closed it immediately. So let's keep this running. Okay, let's throw some more exceptions. There we are. And we can have a look at our task manager, and you can see it initializes the database. And now it's running. We have 7 Postgres backends. Postgres is a process-based database, so you'll see a lot of processes when you run it. And when we exit, hopefully those are all gone. Yep, nice. So with the database available to us for local dev, we can now connect to it from JDBC. So for that, we need the Postgres driver. Let's get that now. Back to our POM. Let's add a dependency on PostgreSQL. Log.postgres, and that's the current version. Once again, we sync our Maven project, and now we can start coding it. So let's come into our application. The first thing I want to do is create a method that queries Postgres to see which version it is running itself. So I want our application class to have a method like this. And for this, I'm going to need a data source so I can get a database connection. Let's assume we're doing dependency injection. We're going to pass this into constructor. And let's just make this a record. It's going to make things a little bit more concise. So we've got a JavaX SQL data source. And you'll note we don't really need to do anything Postgres specific here. Let's just call this DS for data source. And in here, I can do a try with resources. We get a connection from that. From our connection, we can prepare a statement. Postgres has a select version command to tell us exactly what is running. And we can get a result set if we execute a query, just like that. This will always return one row if it works. So we can just go forward to that row and return the value from Postgres. Okay, clean this up a little bit. Let's throw exceptions, SQL exceptions. Okay, so how am I going to create this application instance? Well, let's start testing this from our run local class. So we've got an embedded PG, and we need to create an application now. Okay, we can't pass it the PG directly because what type is this? It's an embedded Postgres type. So we need to call get Postgres database. You see this returns a data source. And hopefully we can get the version directly. Once again, more exceptions may be thrown, but that's fine. If they throw, we will just crash the app. If we do crash the app though, we really want the shutdown hook to run first. So I'm actually going to move this to right after the place we've created the application. Okay, let's see if this works. Once again, a lot of output from the embedded Postgres. And we can see the Postgres version is 14.15. That's actually pretty old. Okay, let's get a newer version. So the Zonkey.io GitHub page explains how to do that. I'm going to just copy and paste something I've prepared earlier. To specify the Postgres version you want, we just specify this special artifact in our dependency management section. I'm asking for Postgres 17. We better tell IntelliJ first. Okay, now what happens if we run this? Okay. And we're now on version 17.2. Okay, I don't know about you, but I'm already getting a bit tired of all this logging. If something goes wrong, I want to know about it, but otherwise, let's make this a little more quiet. For our local development, we can have some specific logging configuration using SLF for JSimple. This is configured by default with a file called simplelogger.properties, which is received from the class path. And we can go org.slf port j.simplelogger.log. And then we specify the logging prefix we wish to configure. And let's just say only tell us about warnings or something more drastic, like an error. Okay, here we go, starting locally. Beautiful. Now we can talk to Postgres. Yay. Right, so let's have a little look at what happens when we send a lot of requests at this thing. So from run local, let's come in here. And I'm just going to put this in a separate method, just so it's a bit cleaner. We're going to create a bunch of threads and just hammer this thing. So let's create a thread pool or execute a service. And we can use virtual thread per task executor. Now, I quite like using these virtual thread executors. They're designed to be created and destroyed frequently. So the basic pattern is create an executor, do stuff with it, and then wait for the executor to exit. So this is a cool way to wait for all the tasks to finish. We can just surround it with the trial resources. We do stuff, we submit tasks, and this code here will only be executed after everything else is finished. Okay, so let's go into a loop. Okay, I will do, and let's create 10 threads to start with. And let's just execute app.getPG version. Okay, and it wants to tell us about exceptions. Okay, let's do that. Okay, let's log when we start. And finish the lookup. Remember, this is executing a query against the database. We need to capture this to a final variable. Okay, final line, it's kind of ugly. Right, but let's see what happens here. Let's see if we run this 10 times or not. Okay, very nice. And let's just log how long this took as well. So we need the start time. And we're going to log the duration. Yep, and we're going to log that. Hammer time, that's milliseconds. Let's put the number of milliseconds per query as well. So we're going to stick this in a constant. Execution, this would do. Okay, lovely. 66 milliseconds to call that 10 times. Right. Where has this gone? Oh, I didn't want that there. Let's stick it right in here. Look. 100 times. What's going to happen? Okay. Average time has stayed the same. That's interesting. 1,000 times? Oh, by the way, we're not running this. Let's get this. Let's get this up here. Okay, there's 6 processes running. That's because we've still got this open. I'm going to shut that down. Okay, now there's no Postgres. Let's start again. Whoa, okay. Something happened then. A lot of connection errors. So we've overloaded Postgres like that. Okay, wow. This conveniently segues into the next section around connection pools. We need a connection pool for 2 reasons, really. One is to speed up connection acquisition time. So we're developing on localhost. It's actually very fast to set up this Postgres connection from our Java app to the database. But if the Postgres instance is on a different server, if there's TLS connections to negotiate or more complex authentication schemes, creating a new connection, which is what we did here 1,000 times, is quite slow and expensive. We want to open a connection and leave it in a connection pool to make things faster. Another important aspect of the connection pool is to manage the number of connections going into Postgres at one time. So if we exposed this endpoint on a web server and we got 10,000 hits all coming in at the same time, we don't want to crash our web server. We want to constrain and perhaps have a connection pool just for our web hits. Let's say we want to allocate 20 requests to our API or web calls. We need a connection pool to manage that for us. Now, there's lots of connection pools out there. What I look for in a connection pool is something with few dependencies, configuration in Java rather than properties files or any external thing, and something just nice and straightforward. For me, that is Hikari. Let's have a look at that. So this is the GitHub page for Hikari. Once again, open source, good documentation, simple getting started here. Maybe a little too much documentation. So let's not worry about this for now. I'm just going to show you how to do this. So first up, add the dependency, tell IntelliJ, and now we can ensure that this is a connection pool rather than a direct connection. Now I'm actually going to refactor this a little bit. Rather than calling the constructor, I'm going to make I guess this is a factory method. And what we are going to give to this is, I'm going to call this the direct data source. And we are going to create the connection pool. So we're going to create a connection pool. Not sure how yet. And then we're going to return a new app with the connection pool rather than the direct source. So creating a Hikari data source is super easy. We just need some Hikari config. We need to tell it data source to use. And it's already got our direct data source. And then we simply create a new Hikari data source with the config. Now the type of this is still a data source, so none of this other code is changing. However, we really should be shutting down our connection pools. So let's make a close method on our app and call ds.close. No, there is no ds.close on a data source. So we actually need to make this a Hikari data source. And now close is working. Okay, let's go refactor our run local. So we use this instead of the constructor. So we come up here. You'll see this doesn't work anymore because this is not Hikari data source. This is quite easy to refactor though, just like that. And the other thing we should do is in our shutdown hook, we need to stop the app. Okay, so we actually need to move that up there. We're going to stop our app before we stop the embedded Postgres. You know, I'm really worried about the embedded Postgres not shutting down processes on my computer. So what if this throws an exception? Okay, let's go try finally 7, try finally. Make sure we're always at least trying to stop the Postgres data source. Okay, this should work. I'm not going to go straight to 1,000. Let's go to 100. I mean 10. Here we go. Okay, so 11 milliseconds with an average time of 1. Let's go up to 100. I mean, we're just getting faster and faster. That's interesting. 1,000. Okay, let's get this open again in case anything interesting happens. Okay, this starting up. Ooh. Okay. Intriguing. 10,000? $100,000? That's interesting. So with 1,000 connections before, we were getting connection errors. How come Hikari can magically do 100,000? So this is all down to the connection pool size. Hikari is constraining the maximum number of connections to Postgres so that it never overloads it. What happens if we constrain the maximum number of connections to 10? So the total time last time was around 3 seconds. And this does appear to be the default. What happens if we allow up to 100 connections at a time? Okay, so we never probably quite needed 100 connections. So what's a good value to use? Well, actually a small number like 10 or maybe 20 is not a bad number to start with. If your queries are fast, you never really need that many concurrent connections. And the more concurrent connections there are, well, you might slow down anyway due to excessive locking or something like that. So just make sure your queries are fast. Start with a small number. As with most performance questions, it's better to measure this stuff yourself and see what happens. So you should be looking at the execution times of your queries, but also we can track the number of connections in use by Hikari. Let's add a method to just log the connection pool size. Now, because DS is a Hikari data source, it's got this Hikari pool mxbean method, and this can tell us a bunch of things about our connection pool. Let's just have a look at the total connections. And let's log that. Where should we log it from? Let's just log it in here. Maybe before we get the connection. Let's see what's happening here. So our connection pool max limit is 100. Let's just reduce this a little bit. Go back to 1,000. I think we need to simulate a slower query here. Let's just stick a sleep in here. 100 milliseconds. Okay. Let's log the size of the connection pool after we've checked the version and see what this looks like with 1,000 executions and a max pool size of 10. Okay, so you can see it is going approximately 1 second, it's doing 10. The connection pool is always maxed out. So we've got these other 900 or so queries just waiting to get their connection. This has a thread.sleep of 1 second, which is why this is so slow now. And this is working exactly as we want. When we're trying to handle a lot of traffic, we don't want to just hammer our database. We want to let them wait until our database is ready for them. So now we've got a database for running locally. We've got a connection pool for protecting our database against a lot of traffic, and it will make our connection acquisition faster. The third part of the PG Highfly stack is Flyway for database migrations, because we need some database tables to actually be able to do anything useful with the database. So the idea behind Flyway is we define our schema in files in our project. When our application starts up, it's going to look in our database, it's going to look in our migration files, it's going to figure out which needs to run or not run, and then it's going to do a migration. And we can do this every time we start the database. Database migrations therefore become very simple. For example, we can add a column in our source code, and that column is going to be available when we next start the app. So let's get started with Flyway. Flyway is no longer fully open source. However, the free version is actually good enough, and I still recommend this for database migrations. So for Flyway, we need 2 dependencies added. First is Flyway core. And then we need a specific dependency just for using Postgres with Flyway. There it is. Same version. We do not use this directly. We can do it at runtime. We tell IntelliJ, and then we can start to use it. Okay, so Flyway, by default, it loads scripts from our class path in a directory called db/migration. We create 1 file per migration, and we prefix it with the version number. So our first one is v0001, a couple of underscores, and let's say we want to create a users table. Create user table.seq. Okay, IntelliJ is saying there's no data sources. I'm going to show you how to load the data source locally in a minute. But let's just create a table called users. Let's say it's got a primary key, which is the UID, and a username. Not null. So in order to get Flyway to pick this up and migrate our database for us, it's actually really simple. Before we create our connection pool, we want to migrate the database. And this is so simple, it's basically a one-liner. So we can go flyway.configure, we can use the default configuration. Like I said, that's going to look in here by default. You can change it if you want. We need to tell it about our data source, which is our direct data source. And then we load it, and then we migrate it. When we start, we can see some logs from Flyway here. It has successfully validated 1 migration, and it's applied our 0001 create users table. Now, running locally, we can have a look at what it's done in our database. So in IntelliJ Ultimate, you'll have this option, database, add a data source, PostgreSQL. Let's paste in this JDBC URL here. Now by default, with the embedded Postgres, the username and password are both Postgres. Again, this is local testing only, so that's fine. Okay, tested our connection, that works. Now I can connect. And if we come in here, we've got two tables. So we've got our users table with the ID and username, and our Flyway schema history. So Flyway is going to create and manage this table itself. You don't need to worry about it. We can have a look at it. It is just tracking what it has applied. So it knows it's done version 0001 of our database. It's got some checksums, and this is how it knows what to run. Okay, and we can come into our users table. We could add a row. This is the UID. Well, luckily we can do that. Okay, here's my username, sorry. And now we have a populatable database. Let's query this out. Let's create a method which just gives us all the usernames. Okay, so once again, try the resources. Get connection. We select the user's username. Execute the query. Let's just make an array list for the results. While we have results, let's just get the user name from it. And we're going to return the results. Okay, let's add the SQL exceptions, and that's lovely. Okay, that's even nicer. So let's come back to our run local. Okay, this hammer time thing is causing too much noise, so let's just query them out here. Let's iterate through them. Yep, that'll do. Okay, so we've added our one user to it. So you think that we will see the one user we added returned, and nothing happened. And in fact, the schema was empty. Let's have a look at what's happening in our database, because we just added a user. And now we're getting connection to localhost 61476 refused. Now that's a suspicious port number. And the culprit here is actually the embedded Postgres. So this library is designed for unit tests. By default, it starts the server on a different port each time. So for local testing, you generally want to be able to see what's happening in your database. So we need a fixed port. Let's go back to run local. We're going to change this. We're going to get the builder so we can build it. We'll set the port to say 21,000. That'll do. And then we start it. Okay, so we'll run it once. We will change the configuration. So this is always going to be 21,000. Yep, that works. Okay. Right, we need to add this again. Now, is this going to work? No, of course not. Next up, by default, embedded Postgres deletes the data directory every time. Again, this can be a great thing for testing if you always want to test against a clean database. Running locally, though, we generally do not want to do that. So to retain a local database with local data, we need to tell it a data directory. I like to make a local or relative path called localDB, so it's part of our IDE project. And we need to turn off cleaning the directory. False. Okay, let's run this again. Okay, so once again, it's had an empty database, it's migrated the data, and hopefully for the last time. We add a new row. Now, if we restart, hopefully we will see some different Flyway logging here. So you can see the current version is 001. It's already up to date, and it's found our user here. If we look in our project, we see a local DB directory. This is the whole Postgres instance for our local development. We definitely don't want to commit that, so let's just make sure we never do. Okay, what if we wanted to add an email address? Can we just come in here and change it from like this? No, we can't. So this is complaining about checksums. So interestingly, Flyway takes a checksum of your script, compares it to what is already done, and it's detected that we've changed the file. So they really don't want you to edit existing files. Instead, everything is additive. So let's add a new migration file. So new file, we're going to call it v0002. Add email. Okay, so we can alter table users. Add column email. It's text. And let's make it not null. Is this going to work? Well, what's IntelliJ saying? The column cannot be added because it's mandatory, but unknown how to fill for existing rows. Well, gee, spoiler alert, IntelliJ, because this is what I wanted to show. What happens when you have an error or your migration fails? You're going to get an exception when you start your service. So here it is. We can't add a not null column without a default value. And if we look in our schema history, well, actually we won't be able to now because our database is not running because this crashed. So all we can do is fix this. Let's just make it nullable. That is a much better way to handle things when you're migrating servers. If we wanted, we could type a script right here to insert default values. But generally, if you're adding to a database, you need to make things optional. You can always have a separate step later on to fully populate it. And once you've fully populated it, then you can make the column not null safely. Okay. Let's have a look in our table now. Okay, we've got a new column, and we can start using this right away. That's enough to get started with the PG Highfly stack. It is a really solid foundation, and you can use this in any application that needs a database connection. Now let's have a little bonus content where we integrate this with a web server, because that is what we need to do a lot. So let's just quickly expose the usernames as a JSON array. So first up, we're going to add a dependency to Webserver. Disclaimer, I'm the main author of this open source server. And we tell IntelliJ to take note. And we can come into our application. Okay, so in our start method, after we've got a connection pool, let's create a server. Let's just hard code the port to say port 3000. We're going to add a handler to get/users. Okay, and we add a handler for this. So we're going to make the content type application JSON. And now we want to query the database, get the user information, and write it as JSON. So we are actually going to need a JSON dependency. Let's add that here. So we'll get the org.json one. Tell IntelliJ. Go back here. Let's create a JSON object. We are going to fill it in here. And then we're going to write it as a string. So to fill it in, we can use our connection pool. Okay. We can prepare a statement. Next from users. Execute the query. loop through them. And for each one, we could put the username as the key in the JSON and the ID and email as the object. Maybe not the best API design, but it'll do. So the username is username. That's the email. The user ID is an interesting one. It is a UUID column in the database. And I believe we can simply cast just like that. We're going to find out anyway. So let's just put JSON.put, like I said, we'll put the username as the key. And then we'll put the email and ID just like that. Okay, better finish those lines off. And finally, we start the server. And we better be good. We better shut down the server as well. So let's add that to the constructor just like that. And when we stop the service, first thing is we want to stop the server. Okay, great. And let's log that we've started the server. So we've got server.uri.resolve/users. Okay. Did we get in one shot? Let's find out. And there you go. Let's just quickly make sure the email thing is working. Let's add a new row. Generate a UUID. It's a totally different person. Okay. Back to our browser. And now we've got 2 users here. How nice. Well, thank you for suffering through that with me. Hopefully you found it useful. This source code is on GitHub. You can get it for your reference. See the description below, and see you next time.